Why, hello there, fellow calculus students. Let's start off with the real question here. What is a definite integral? Well, funny you should ask. A definite integral can be defined as a function continuous on an interval that is divided into subintervals, represented by delta x, such that x subscript I lies on the ith interval. Now that we know what a definite integral is, when does such a thing exist? It exists when the function is continuous on the interval a to b, or has an infinite number of jump discontinuities. We use the definite integral to find the area under a curve. We can also use the theorem from the textbook to solve for a definite integral value. Now that we're ready, let's get started. Number 21. Use the form of the definition of the integral given in Theorem 4 to evaluate the integral. To do so, we will need two key pieces of information. We will need x subscript I, in addition to the second part, delta x. Taking a closer look at these two values, we will discover that b is equal to 5, a is equal to 2, and plugging that in will yield 3 over n. This allows the subintervals to come to 0, 3 over n, 6 over n, and 9 over n. The x subscript I value is 2 plus 3i over n. We can now begin to evaluate the integral using Theorem 4 from the textbook. We will substitute x subscript I for the value we found it to equal, which is 2 plus 3i over n. We can then do the same thing with delta x, which we found to equal 3 over n. Now, we can move that delta x value, 3 over n, right behind that limit. We also can take the x subscript I value and sub it into the original equation of the function. Multiply the 2 into the bracket to get negative 4 minus 6i over n. The 4's will cancel, and as you rewrite the limit as n approaches infinity, you will multiply the 3n to the 6i over n. I, and we use summation to change the notation. As we cancel, calculate, and evaluate the limit, we get a final answer of, drumroll please, -9! Congratulations, guys! So back it up. What exactly did we just find? Well, technically, we found the area under the curve, sorry guys, I can't spell, between 2 and 5. Great job, everybody, and thank you very much for stopping by. Have a good one.